Okay, so the next section is nth roots, and um, it's just other types of radicals other than a square root. We've done cube root a little bit, but this gets into fourth root and fifth root and so on. So there's a few things to pay attention to. First, basically, the reason we'll have an nth root is if a raised to n is equal to b, then a is the nth root of b. For example, if you have 4 raised to the third is equal to 64, then that means the cube root of 64 is equal to 4. And it's just an inverse operation to an exponent, okay, other than 2. So we talked about this a little bit, but if n is odd, meaning if the root is odd, then there is one real root of b, and it's written the nth root of b. Where if it's even and the b is positive, what's inside the radical has to be even in order for you to be able to take the nth root of it if the n is even. And there are two real nth roots, the positive and the negative. If b is negative, if you have a negative number inside the radical, then there are no real nth roots if the n is even. So if it's odd, you can always do it, whether it's positive or negative on the inside. If it's even root, then it has to be a positive on the inside in order for you to be able to simplify it. The only nth root of 0 is 0. So it doesn't matter what the root is. If you're taking the nth root of 0, it's going to equal 0. Understand some parts to it. The n here is the index. I'll call it a root sometimes. The index or the root. The radical is the radical sign. And what's under the radical is the radicand. So if it has a plus or minus in front, you're going to have a plus or minus in your answer. And that's going to be if it's even, where if it's odd, you're going to either have a positive or a negative out in front, and it's only going to be 1. So this is the square root of 16x to the 8th. So you want to find out what times itself is 16x to the 8th. Well, what squared is going to be 16 is going to be 4. And what raised to the second is going to be x to the 8th. So if I have something like this, what number is going to go here? What would happen is I multiply these, so this is going to be 4. So I have the square root of 4x to the 4th squared. Well, that's going to become 4x to the 4th. Basically, the square root and the squared cancel each other out, and I'm equal to 4x to the 4th. I'm going to show you a shortcut here. I don't like changing this way. The shortcut basically is your root here, your index is 2. Okay, so you take the root of that number. This is going to be square root of 16. Well, that becomes 4. And how you do the variable, you take the root, divide it into the exponent, and that's how many will come out. How many times does 2 go into 8? 4, so that becomes x to the 4th. So it's 4x to the 4th. So for this one, you have the whole binomial that's being raised to the 4th. So basically, I'm going to do the same thing. This is a square root, so that's a 2. You don't need to write it. If it's not written, it's understandable that it's a square root. So 2 goes into 4 twice. So that means that when I take the square root of it, it's this, whatever was being raised to that exponent, which is that binomial, q raised to the 3rd plus 5. 2 goes into 4 twice, so that's going to be a 2 in that exponent there, and this is a minus. Let me look at this one first. The square root of negative 4. Well, because this is even index and it's a negative radicand, that means there's no real roots. If you're using i's only work with the square root. So in this case it could, but remember it only works with a square root. And for this one, I have the fifth root of 243, a raised to the 10th, b raised to the 15th. So for the fifth root of 243, we're going to do the factor tree or birthday cake here the same way we did before. I'll do the birthday cake in this first one. I'll do another one later on as with the factor tree. But I'm going to divide this by a prime number, and I get 3. This becomes 81. Divide it by 3 again, 27. Divide by 3 again, and I get 9, 3, 3, and 3, and 1. The key here is this isn't a square root. When it's a square root, I was looking for a pair of 2's. Well, this is a fifth root, which means in order to bring one of the group out, I need to have 5 of the same number. If I don't have 5 of the same number, I can't bring anything out. So here I have 1, 2, 3, 4, 5 3's. So that means the fifth root of 243 is 3, and there's nothing left on the inside. 5 goes into 10 twice, so that becomes a squared, and 5 goes into 15 3 times, and that becomes b to the third. And so this is the simplified form of the fifth root of 243, a to the 10th, b to the 15th. So there's some detailed parts here that we're going to go through with simplifying and using the absolute value. If the root or the index is even and the result is odd, you must have the absolute value under your result or your answer. So for this one, the root is even. So when I say 6 goes into 6 one time, so that means t to the first comes out. Because the result is odd and is a 1, I need to have the absolute value around this. So it's the absolute value of t. And so for this one, this is a fifth root. Well, it's odd. I don't need to be concerned with the absolute value parts. Okay, just solve it or simplify it normally. We already did the fifth root of 243, which is 3. And then 5 goes into 15 3 times. So that's going to be x plus 2 raised to the third. And there's nothing left inside the radical. The square root of 36 is 6. And the square root of y to the 6th, well, this is squared root, so 2 goes into 6 3 times, so that's going to be y to the third. I don't need to use the absolute value with the coefficients, only with the variables. So because this is a cube, y cubed, and that's odd, the root was even, I need to have an absolute value around that y cubed. And this last one, the fourth root of 16 is going to be, well, let's go ahead and do the factor tree for this one. The fourth root of 16, if I do the factor tree, I get 4 times 4, 2 times 2, times 2 times 2. And because it's a fourth root, I'm looking for 4 of one number. I have 4 2's, so that's 1 2 that comes out. Nothing is left on the inside. There's nothing remaining. 4 goes into 12 3 times, so that's going to be x minus 3 raised to the third. But because this is an odd root, or I'm sorry, an odd result, an even root, I need to have the absolute value on it. All right, here are a couple U-try problems. I grouped them all into one. So if it needs an absolute value, go ahead and put the absolute value on it. Go ahead and pause it. So here are your 3 answers. The square root of 64 is 8. This is an index of 2. 2 goes into 12 6 times. 2 goes into 10 5 times. Because it's an even root and an odd result, I got to have the absolute value around just that one. This one was even, so I didn't need it. This is an odd root, so I'm not worried about the absolute value. Cube root of 8 is 2. 3 goes into 12 4 times, so it's x to the fourth. And this last one, the fourth root of 81 is 3. And I'm dividing this exponent by 4, and that goes in 3 times, so it's x plus 4 cubed, and it's an odd out of an even root, so it needs the absolute value around that whole thing. There you go.
All right, see if you can get this one. It has a little holiday theme to it, even though it just passed. What is a vampire's favorite holiday?
Thanksgiving.